Hey everyone, welcome back to another edition of No Here, No Problem. Today we're going to be working on Unit 3.6 notes, which is nonlinear models. I'm going to be upfront and tell you that this entire objective, 100% of it, for the most part, I should say 100%, is going to be calculator based. And so it's technology using either your TI graphing calculator, okay, which you have some variation of this, or you're going to be using Desmos. What I'm going to do is I'm going to do the entire video first using the TI graphing calculator, and then I'm going to do the second part of the video going through doing the Desmos stuff. And I'll let you decide which way you want to go about doing it. If you plan on doing the Desmos, jump ahead. And if you're planning on doing the graphic calculator, we're going to start with that first because I know the majority of people have that calculator. You determine which one works best for you, but just in my opinion, Desmos beats it every single time, and you'll see why at the end there, okay? What we're doing in section 3.6 is we're working on what's called nonlinear models. And what we're really doing is we're doing regression. We've talked about in the past linear regression, which is when you have a whole bunch of data points given to you. And what you're doing is you're looking at those data points and determining what's in line of best fit. Now, in the past, we've done linear regression. Well, in this, we're going to see that there's not always linear regression take place. Sometimes we have linear, exponential, power, log, logistic. There's a multitude of different regressions. We're going to experiment with them. And in order to know which one is actually the best one, we have to know first a definition called the R squared definition, or R2 value. That R squared value that we're talking about is the coefficient of determination, or R squared. It's this measure that we use in statistics that can be found using statistical formulas. I'm not going to get into that. If you're worried, you can learn about it on online or go ahead and look into them in statistics. But that R squared value is a correlation coefficient, basically, that's between -1 and +1. The stronger the correlation, the closer that number is going to be to a +1. So let's get started on some problems here. I'm going to go very quickly because here's what happened. I actually took and preloaded most of this stuff onto my calculator so I can go quickly through these, okay? In this first problem right here, and in actually in A, B, and C, I'm only going to do the first one. You can go ahead and do B and C on your own, but I'm going to walk you through how to put that first one and how to get each one of those values there, okay? So we're looking at linear regression, exponential regression, and log regression. I can tell you right now that this graph right here is in fact the graph of these points that are right here. So when we look at this graph, we can see the graph kind of goes up as it goes along. So it's not probably going to be a linear regression. It might be an exponential or it might be a log. We don't know yet, okay? But what we're going to do is we're going to figure that out using our calculators. So I'm going to go ahead and turn to my graphing calculator right here. Now, to how to use this whole thing. There's several buttons that we need to go through first. First one you're going to need to know is this button right here in the middle. This is your mode button. That mode, we have to go in there before we do any regression and make sure things are turned on. So go into mode. And what we have to do is go down first, all the way down to where it's at. Whoops, I went right past it. We're going to go to where, oh, geez, fingers. We're going to go to where it said stat diagnostics. Okay, right there. And we want to make sure the stat diagnostics is turned on. So what we're doing is we're telling our calculator we're about to do some statistics, okay? Once that's turned on, you go to on, you hit enter on it, and that goes and turns it on. You're going to hit second mode, and that's going to quit you back out. Now, to get statistics on our calculator, we're going to actually use the button that we see right here, which is the stat button right in the middle there, okay? That's that button that has that cursor on it. So we're going to go stat. And we're going to go ahead and edit first, okay? So we're going to hit enter. And I, as I said, have already preloaded all of the statistics for that problem onto it, okay? Of course, my fingers are too big for the screen, so I keep tapping out of what I need to, okay? So you can see that these are the points that are actually matching up with that very first problem that we had. From here, when we look at the graph, now this graph turn on is kind of a bit of an ordeal, so let's make sure we understand. You see right here on the screen where it says plot? That plot button, what we're going to do is we're going to activate it by hitting second and then plot. So we're going to hit second plot, and at the top, this is normally set to the off button. We're going to turn it to the on button. When you're done doing stats, you always have to go back and turn this off. So for the sake of this, though, we're going to go ahead and turn it on. Okay, you can see it's turned on. And then what we're going to do is we're going to go back to our zoom and we're going to go zoom stat. So we're going to go zoom right here and then we're going to go stat. So zoom, and then we're going to go down on this option here all the way down to number 9, which is stat. And you'll see what it's going to do is it's going to graph this equation on my calculator. Okay? Or I'm sorry, all these points on the calculator. So you can see we have the basically same exact thing. This is if I wanted to do a graph of the points, which you're not always required to do. I just wanted you guys to see how to do it. If I want to go ahead and do the regression, we're going to go back to the stat button that's in the middle there, the stat button. And this time what we're going to do is we're going to go to the right to where it says calc. So that calc button right there, you'll see as we go down, there's all different kinds of regressions. So you can see as we talked about, there is the, oh my gosh, I got to use my stylus. I keep touching the wrong buttons here. Okay, so there's linear regression, quadratic regression, cubic regression, quartic regression, which we don't really use, another linear regression. You notice that number 4 and 8 are exactly the same. The only difference is that we have ax plus b versus a plus bx. Normally we use number 4. It's not going to be the change of the world if we do the other one. Just we usually stick with number 4. We have natural log regression, exponential regression, power regression, and then that is all the regressions that we're going to do. So for this first problem, if you go back to it, it says, let's find the linear regression first. Hit enter, and then we're going to hit enter again. And what that will do is take us to the screen. And you can see right here, it gives us an r squared value. That r squared value, when we look at it, is 0.886, I believe. Let me see here. I think I accidentally changed the data somewhere there. 2, 1, 2.5, 1.2, 3, 1.3, 3.5, 1.5, 4, 1.8, 4.5, 2, 5, 2.4, 2.5, 3.1, 9.5, and 10. Yeah, we got everything. I don't know. All right. So anyways, that's our first regression value. Okay, so we get a 0.8868. Okay. I got 0.8825 the first time I did it. I don't know what happened. So let's go ahead and we're going to do again. This time we're going to calculate and we're going to do the exponential regression. So we're going to go down and do exponential regression. And for this one, we're going to get 0.99. Okay. Then we're going to do one more time. We're going to calculate the regression we're going to do log regression. Okay. And for this one, we're going to get nope, that's the wrong one. Sorry. I don't think a plus b natural log n. That is not a regression that we actually have on this calculator. So regardless though, the log regression, I'm going to go ahead and just do exponential regression. Nope, sorry, log regression. So I'm going to do this one right here. And I'm going to go ahead and get a regression value of 0.739. Doesn't matter, it's still not very close. In your notes, it says a plus b natural log x, and you'll see that this matches up with it, okay? So when we look back at this, these are the 3 regressions that we just actually calculated from the calculator. And what you could see is the one that has the highest r squared value, because the closer to the one it is, the more correlated it is. When we look at the exponential regression on this one, it's got a 0.9946 regression. That is far stronger than these other 2 regressions. So we would say that this equation right here is going to be by far the best equation. Just to prove it, what I'm going to do is I'm going to actually go back. I'm going to go ahead and calculate the exponential regression. And then there's a way to actually store these in the calculator so it'll actually graph it. Oops. Stat, calculate, exponential regression. What we're going to do is we're going to go down here to where it says store regular equation. We're going to store this equation right here in the calculator so it actually graphs this equation. To do so, you're going to go down to where it says store reg equation. And right here in the middle where it says vars, you're going to hit VARS. It's going to take you to the screen. You're going to go to the right screen, which says YVARS. And then the very first option right there is Y1, and you'll hit enter. And what you just told your calculator is we're going to take this and we're going to store this equation into y1 so I don't have to physically copy it. Hit enter, you'll see we get the equation. The equation is 0.506 times 1.367. So that's going to go in for your a value and b value here, and that's going to be raised to the x. If we go into y equals, it's already put this into our calculator for us. I don't have to retype it, it automatically put it in. And then if I go to the graph button, you'll see that the equation actually pops up there and actually shows the equation. Now you'll see for this one, the line of best fit says that we're going to try to hit as many points as possible. We're going to have some that sit above and some that sit below, but we'll have this line that kind of goes right down the middle. Okay? It was a lot to try to do there. What I would recommend is go back, try to do these several times on your own, pause it, but come back and check. I'm going to go ahead and just show you the other ones here so you can see that these are the values for the second equation. You can see that the best one in this is actually this one, I'm sorry, the log regression one right here. And then for the last one on here, we're going to see that the best equation is linear regression right here, that a line would pass straight through it. That's going to be the best one, okay? If we continue on, we're looking at, for this one, we're saying, let's go ahead and graph these points, put those into our equation, or I'm sorry, into our calculator, and let's do the regression for this. And they're asking us to do the exponential power, so all we're doing is practicing doing this again. So again, I would recommend pausing it, try to get these exact same values that you see here, that when we look at the exponential regression, power regression, the a value and the b values are provided for us already. You got your a values here, and you got your b values here, okay? The r squared value in the exponential function is 0.994. That's obviously higher than the r squared value in our power regression, which was only 0.93. So that tells us that there's a stronger regression in the exponential regression function. So if we look at the graph of this, you can see that one graph clearly seems to fit the data better than the other. Okay, and that's all we're looking for, is the line of best fit. So let's go down here. On this problem, all we're doing is we're taking the points, we're putting them into our calculator again in stat, and we're looking at the linear regression and the exponential regression. Now, disclaimer on this, log regression here is not going to work for us. The reason being is that this 0 point that's right here, if I put in log of 0, we know that we hit a domain restriction, and we end up with an error message as a result. If I do the power regression, it's going to give us the same thing. We're getting an error message. Logistic regression is going to work. It's going to give us just a really wonky equation. We're not really looking at logistic regression, so you can just really just do linear and exponential for this problem, just for the practice. And what you're going to see is when all is said and done, this 0.9988 is going to be the highest value, so that's an exponential regression, obviously. And again, you can see that these are the values. Make sure yours match up. And then if we looked at the equation, then putting those in, we have this equation of 10.084 times 0.877 raised to the x power. So for the next part of this, it says, well, how much is left after 15 days? That's our x value. And so when we put in that 15, we're going to be left with 1.408. Now that number should kind of make sense, because that 1.408 after 15 days, when we look here, we have 18 is over here. So 17, 16, 15. What we're saying is that I'm putting a value right about 1.4 is going to be right about like here. And we can see that if I continue the trend of the graph, it's going to kind of go towards that point. Okay. So that's regression on the graphing calculator. Again, go back, watch it again so you can understand exactly how to do it. But it's really, generally the mistakes are people forget how to put in certain points, like they might make a little slip up with things, like the numbers are supposed to line up on the bottom of our chart here. If they don't line up, you mismatch something at some point. And then the most annoying thing for everybody is when they go to do graphs, they forget to turn the plot off. So remember, you're going to go second y equals, and you're going to go back up and turn plot off. That way, when you go back to the graph, you'll see only the line. And since you accidentally, or you didn't actually, you intentionally messed with the zoom, you want to put the zoom, go back to standard, which is going to be 6, and it puts it back in the standard form. Okay, so that concludes the graphing calculator. Let's look at Desmos, the glorious Desmos, okay? When we look at Desmos, I went ahead again and I preloaded all the equations for this, and this is just from page 2 of the notes. This is what the regression looks like on the calculator. Now, to type in, to create these tables that we're seeing here, all you literally have to do is type the word table and it just pops up a table that you can fill in. Watch, I'll go in here, I'll type Table. Boom, it pops up a table for us. And then you start filling that in. Okay. So when we look at this, I've got all the data in here. Now, this is the coolest part. You ready? On the left side of your table, right here, this button, you'll see that this is a regression button because you can see there's a line in between points. If you touch that point right there, it creates a regression. If you look down here, it will create the functions automatically for you based on what you choose. So if I go ahead and I do a quadratic regression, you can see that the points follow my curve. If I do a exponential regression, you can see the points follow my curve. Now, this is a caveat that I had to actually read about. I didn't realize this had it on here, but when you do log mode, you have to actually click on this. Anytime you do exponentials and logs, you have to choose log mode to get the same statistics as you would on a graphing calculator for this, okay? It's just a more accurate base 10 model. If you do logarithm, you can see that the graph does not actually match. You do power regression, you can see it sort of matches, and so on and so forth. Here's the logistic regression, and there's that wonky function that we talked about, and you can see the R-squared value is 0.9948 for this, which is pretty darn good. But again, in this original problem, we said it was exponential regression, which, if you remember our discussion before, exponential is just the beginning of logistic growth, okay? So I'm going to turn that one off so that we don't have to see that anymore. And now let's go to the second one. Same exact thing. I go ahead and I type them in. I turn this on. You can see our points. You can stretch it and move things around. I'm going to go ahead and hit that little icon next to it, and you'll see it creates a line. We look at each of the R values. Linear regression is this one. Quadratic is this one. And the R squared is 0.9913. And then we look at the, what was the log regression? And you can see, boom, this one fits pretty good. And if you look at the R squared value, 0.995, that's the largest R squared value here. And this is one that seems to fit the data pretty well. All right, let's continue on. So you can see I did that for each one of them. Again, each one of them here. So let's get to the very last one here. The very last one was the one that was on page 5. So on page 5, this is the data right here. If we look at the function, this is where we're at, okay? And if we look at the actual regression line, we said that the exponential regression was the best. You can see that we get an R squared value of 0.999, which is as close to 1 as you can really get. And so that tells us that this is the chart that we're going to want to use. And then if we want to write down this equation, we can. I'm going to push a button here and see what happens here. I can actually, oh, there's the equation. So now I can actually go in there and change that x value to be equal to 15 to see what it actually equals. Let's see if I can get it to do that. All right, 15. What do we say after 50? Yeah, so after 15. So we're going to put in a 1, 5, and you can see we get that 0.1417. Okay. And the button that I pushed there again was once it was plotted. Let's see if I can actually put in that value, 15. Nope, it didn't give it. You can actually get it to create the equation to play with it, but again, that button that I just hit was this button right here. That went ahead and pull up the equation for us, and that allows me to now work with the equation to change values that I want. So again, in this case, we change that x to a 15, and there's the equation. So with that said, it's, as I said, it's really up to you. You choose which method you want. The graphing calculator is always good. Desmos is the calculator that's going to be built into standardized tests that you're going to do. Either way, up to you how you tackle it. Just make sure you know how to do at least one of them, okay? That's it. That concludes Unit 3. You guys take care. Let me know if you have any questions. Otherwise, stay safe. Don't forget to like and subscribe. And we'll see you soon.